Welcome to Gradeful, where we provide one-on-one and small group tutoring for the SAT, ACT, and PSAT. We tutor students all around the world. Your competition is definitely using a tutor for their next big test, and they're probably using a good one. So if you want the competitive advantage, feel free to reach out and find out how we can help you prepare for your next big test. Right now, we're looking at the April 2021 Section 3 Math, Non-Calculator Math section, and let's go ahead and jump right in. Question number 1 is asking us about some basic exponent rules. First thing you can do is think of the 12 and the 8 as a regular fraction that you can simplify by 4 by dividing the top by 4 and the bottom as well. So 12 divided by 4 is 3, 8 divided by 4 is 2, and the exponent rule for when you have division with the same base in a situation like this would be that you subtract the exponents. So we can just go ahead and make this x to the 3 minus 2, which is x to the first. And so that's 3 halves of x, which is equivalent to 3x over 2. And the answer for number 1 is B. Question number 2 is a really interesting question that's asking about the definition of a solution. If you have a single curve, like a parabola or like a function to the third or fourth power, with a single function, the solutions are the x-intercepts. However, if you have multiple functions, the solutions are the places where those functions intersect one another. So we have two totally different definitions of what a solution is, depending on whether you have one function or multiple functions. Here, of course, we have two functions, so the solutions are going to be these two places where the two functions intersect. And according to that definition, the point -1, 4, this point right here, is satisfying both equations. It's the place where both equations intersect, and in that sense, it's our solution. So the answer for number 2, believe it or not, is C. Question number 3 is getting at the definition of an f of x expression. If I have something like h of t, or in general we can call that an f of x, if we have something like that, we can say that the entire thing is the y. So f of x or h of t, that's our y, and the thing in the parentheses, that's our x. So seemingly obvious to some, but these little details make all the difference in the world. So when the question tells us h of 2 equals 11, they're telling us that x is 2 when y is 11. Now, what are x and y in this situation? We were told that the function h, which is the y, is representing the height of the ball. And we're also told that the t is the number of seconds. So that's our time. So how can we interpret the 2:11? At a time of 2 seconds, the height is 11 feet. And that matches answer choice C for number 3. For question number 4, we're subtracting these two expressions. And the first thing you're going to want to do when you have a negative sign outside of a parentheses is, well, first you want to think of it as a -1. So I'm just going to write -1 right here outside of that parentheses. And it just kind of helps us to think about this more accurately because a negative sign is really a -1. And if you distribute that -1 to the two pieces that are in the parentheses, so we're going to distribute it to the 2x to the 5th and to the 3x to the 4th, -1 times 2x to the 5th is -2x to the 5th, and -1 times 3x to the 4th is -3x to the 4th. Bring down the other two terms. And now we can just combine our like terms. Right here we have 4x to the 5th minus 2x to the 5th. So 4 minus 2 is just 2. And here we have 5x to the 4th minus 3x to the 4th, which is 2x to the 4th. So we have 2x to the 5th plus 2x to the 4th. And the answer for number 4 is B. Question 5 is about a very important higher level theme for the SAT. About the idea of if you have something that's every, let's say, a amount, or a times every amount. So we'll show you what that means. As a regular y equals mx plus b, this would be a situation where we start at 212 and then we decrease by 1. So in other words, the y-intercept is 212, and the slope is -1. So on a more basic version of this equation, this would be what the equation would look like. But the one thing we haven't addressed yet is the idea that this is happening for every 500-foot increase in elevation. So the idea of that is if this were happening every 500 feet, it's going to be expressed as x over 500. And if it were 500 times per foot, then it would be 500x. And that little difference there is super important. It's coming up on every single SAT. So instead of -1x plus 212, we're going to replace the x with x over 500, which is saying that this same change we're talking about is happening every 500. So y equals -1 times x over 500 plus 212, and that's exactly equivalent to answer choice A for number 5. Number 6 is about another common theme on recent SATs, and that's the idea of competing amounts. So in this situation, the number of goats is competing against the number of horses. For instance, we can have all goats and no horses, or we can have all horses and no goats. And so the number of goats and horses are kind of competing against each other. You can think of a point somewhere in the middle as kind of a compromise where there's half the number of horses and half the number of goats, just generally speaking. But the useful thing when you're in these situations is to think of the x and y intercepts as a great way to make better sense of this. So if we're talking about horses only, what you want to look at is the moment where there are all horses and no goats. So the x-intercept in this situation. At that moment, we have 5 horses and we have 0 goats. And so 5 horses and 0 goats. But if there are 10 acres, the question is asking us for the amount of acres for each horse. So let's just go ahead and write that as a unit. Acres per horse. And the number of acres we have available is 10. The number of horses is 5. So simplify that, and the acres per horse is 2, which is why the answer for 6 is A. Question number 7 can be thought of as a question on graphing inequalities. There are really a couple of ways to handle this, because you could plug the values that you have in for x and y into that equation, or you can think of it graphically like we're about to do here. So I'm just going to draw a little graph with 5 units on each side. And for this, what we want to do is think of the equation that matches this inequality. So instead of y is less than x minus 4, we have y equals x minus 4. And that would be the same as y equals 1x minus 4, which now looks a little more like mx plus b. So we know that our slope is 1 and our y-intercept is -4. So graphing this, we can go to -4 on the y-axis, and then we can apply a slope of 1 over 1. So the slope is 1, which is the same as 1 over 1, and 1 is our rise, and 1 is our run. So every time we go up 1, we're going to go over 1, and it's going to give us a perfectly even slope. And in a situation like this, because we're going up 1 and over 1, if you're hitting at -4 right here, you're going to hit the x-axis at 4 right here, because we're going up by the exact same amount as we're going sideways. So let's go ahead and fill in that line there. And so that's our line if we were graphing a line, but it's actually an inequality. And one thing to know is that less than or greater than would be a dashed line when you're graphing these kinds of things, and less than or equal to or greater than or equal to would be a solid line. So because we have less than and not less than or equal to, I'm just going to go ahead and delete little bits of this line to show that it's actually a dashed line. And the other part of this is that these two inequalities, the less than ones, mean that you should shade below. And these two inequalities, the greater than ones, mean that you should shade above. So because it's less than, we're going to go ahead and shade below. And it looks a little something like this, where we have that dashed line and we're shading below it. And so which of these points is likely to be in that area? Seeing it now, we can kind of do it a little quickly. 0, 3 is clearly not there. 3, 0, it's just a little bit outside. 0, 6 is up here, and 6, 0 is right around here somewhere. And so that's in our solution area, and the answer for number 7 is D. So question number 8 is giving us some right triangle trigonometry here. So they're telling us to have a 90-degree angle called P, and there's also a Q, and the length of side PQ is 70. Now be careful, it'd be really easy to think of that as an angle measure because 70 sounds like an angle, but they're telling us it's a length, and the measure of angle R is 38 degrees. So we've got all of the information that was given to us, and we're being asked for the length of side QR, which for now we can call X. So in trigonometry, whatever angle you're given, whatever specific angle, that's sort of your vantage point. And from there, the first thing you want to do is go opposite that angle and call that your opposite. The hypotenuse is the one across from the 90-degree angle, so that's labeled hypotenuse, and the one left over, that's our adjacent. And of course, we're talking about SOHCAHTOA, which is a little saying that tells you how to arrange the different angles in a trig triangle. So with these being the opposite, hypotenuse, and adjacent, the two sides that we're working with are this one and this one, the opposite and hypotenuse. So opposite and hypotenuse, that's right here in SOHCAHTOA. So we're dealing with the sine right now. So let's go ahead and do that. Sine of this 38-degree angle is the opposite over the hypotenuse. And it's a little more tricky when you have x on the bottom there. First thing you want to do is just go ahead and multiply both sides by x. So you get x sine 38 equals 70. So let's just rewrite that. X sine 38 equals 70. And on the right-hand side there, x cancels with x. That's why we only have 70. And the next thing to do is to divide by sine 38 on both sides to get that x by itself. So that'll give you x equals 70 over sine 38. And so the answer for number 8 is B. For question number 9, we're being given a table, and the table is a little hard to see, as is common on a lot of these situations where you can log in and see the test questions on the College Board website. But I'm just going to put this sort of grid here so you can kind of make a little better sense of it and see that everything in the left column would be the x values, and everything in the right column would be the y values. So we're being asked about a linear relationship, which is a y equals mx plus b. And so the first thing you're going to want to do is get the slope. Your slope is your change in y over change in x. And every time x is changing by 3, because it's going from 2 to 5, the y is changing by 1/2. So a little more on the complicated side compared to some of the basic slopes that we deal with regularly. But if you're dividing fractions, then you want to multiply by the reciprocal of the denominator there. So this would be 1/2 times 1 over 3. And that's 1 over 6, and that's our slope. So we already kind of know that C and D are the only two that are right because they have the correct slope. So now we can get the y-intercept, and what we basically have right now are a bunch of points and a slope. So we can use the point-slope formula of the line, which you definitely should know by heart. Y minus y1 is mx minus x1, and we can plug in any of the values. Of course, we're going to want the easiest one, so I'm going to plug in 2 for x and 1 for y, and they go in these two spots. So the x is 2 when the y is 1, and let's go ahead and fill in everything else. The slope is 1/6, so it looks like that right now. Now we just need to simplify, so we can distribute the 1/6. 1/6 x minus 2 over 6, which is 1 over 3, and then add 1 to both sides. Negative 1/3 plus 1 is positive 2/3. So y equals 1/6 x plus 2/3, and so the answer for number 9 is D. So question number 10 here is talking about perpendicular slopes, and perpendicular slopes are negative reciprocals of one another. And so we'll demonstrate that here. The slope of line M would be rise over run as you go from left to right. So let's go ahead and pick this as our first point. and this as our second point. And as we go from this point A to point B, we're rising by -2, and we're running by +1. So -2 over 1, which really is just -2. But since we're getting the perpendicular to that, we'll leave it as a fraction. So the slope of line P, which is perpendicular, is going to be the negative reciprocal. You're going to have to flip it over and multiply it by -1, which is actually going to make it positive. So the slope is +1/2, which matches only one of the answers, and y equals mx plus b. The m is 1/2, and the answer for number 10 is A. Question number 11 was labeled as a hard question, which is kind of laughable because if you've been following along with what we're doing and you know our one-liners, you know that the y-intercept means that x is 0. And by the way, the x-intercept means that y is 0. So if you just pick up on that reference, then we can make x 0, and it looks like this, and just start simplifying. Y equals -4 squared plus 3, which is 16 plus 3, and that's 19. So we just found out that y is 19 when x is 0, and I just can't imagine how that would be considered hard. But as with many concepts on the SAT, when you know the textbook way to do it, it is quite easy. And if you're kind of really trying to understand this as the graph of a parabola with a vertex of 4 and +3, then yeah, this would be a little more difficult, but we don't want to go that route. So the answer for number 11 is D. Question number 12 is giving us another code word. It's asking us for the minimum value. And we also know that this equation that they're giving us is a quadratic. A quadratic is something in the format of y equals x squared, or something a little more complicated than that. It's a parabola. So for the minimum value of a parabola, that's code for the idea of the vertex. And for the vertex of a parabola, that would be -b over 2a if your parabola is in an ABC form. And if it's in a factored form, where you see the two, usually the group of 2 parentheses, then the vertex in that situation would be the average of the zeros. So depending on what format you have, you can do the vertex 2 different ways. And of course, you want to always be using the easiest way for whatever it is you're being given. So in this quadratic, our a is the number in front of the x squared, which is 1. Our b is the number in front of the x, which is 4. And our c is the constant at the end, which is also 4. So what's -b over 2a here? That would be -4 over 2 times 1. So -4 over 2. So it's -2. And that is the x value of the vertex. Now, there's another subtlety here that's really important. When you're talking about functions, if you're being asked, where can I find something? Where is the minimum value? That's a reference to the idea of the x value. But if you're being asked, what is something? What is the minimum value? That's the y value. So here they're asking you, what is the minimum value? So in a really subtle way, they're not asking you for x, they're asking you for y. So don't put it past the College Board to make -2 a possible wrong answer here, and a lot of people might pick that because they found the vertex but didn't realize that they're not being asked for the x, they're being asked for the y value. So now that we have the x, we can just plug it back in to get the y. So f of -2 is -2 squared plus 4 times -2 plus 4. So -2 squared is 4. 4 times -2 is -8 plus 4. And we have 4 plus 4 minus 8, which is 0. And so the y value of the vertex is 0, and that's the minimum value for our function. Now, just a little bit more about the min or max of a vertex. If a vertex is an upward-facing vertex, it'll have a minimum value and no max. If it's downward-facing, it'll have a maximum value but no minimum value. Now, we knew that this was an upward-opening parabola because the sign in front of the x squared, the sign of the a coefficient, tells you which way it opens. If that were positive, it opens upward. If it's negative, it opens downward. So because here we had positive x squared, it was going to look more like that, and it was going to have a minimum from the beginning, which we just found out happens at -2, 0. So the answer for 12 is D. So question number 13 is asking about special kinds of solutions, as in having no solutions or infinite solutions. So for instance, if you had an equation like this, in the next step, you'd naturally want to be taking away 5x from both sides, and that's going to give you just 7 on the left and negative 3 on the right. And what you're supposed to know about these situations is if your variables drop away and you end up with a true statement, then the answer is all real numbers. If you end up with a false statement, then the answer is no solution. So in this example I created, the answer would be no solution. And that's happening here in 3 out of the 4 answer choices. In answer choice B, if we took away y from both sides, we would literally have 0 on the left and negative 5 on the right. That's a false statement, so the answer for B would be no solution. C, same thing. If we take away y from both sides, we get 0 equals positive 5, which is also false. And on D, if we take away y from both sides, we would get 5 on the left and 5 on the right, which is all real numbers, infinite solutions, which is not the same as one solution, which we're looking for. So the only answer that we can pick for 13 would be A. So now, just to understand A a little bit more, in this situation, the instinct would be to add y to both sides here, and you would end up with 2y equals 5 divided by 2, and y equals 5 over 2, or 2.5. So we actually did see this demonstrate that it has one solution, which is what we're looking for number 13. Question number 14 is asking us about graphing exponentials, and the first thing you want to know when graphing an exponential function, by the way, exponential means that x is in the exponent spot, which is what we see here. The first thing you want to know about that situation is to look for the 0 exponent. So in other words, what's the value of this whole thing when x equals 0? Because if there's only one graph that has the right value for that, then we'd pretty much be done here. So if x equals 0, you'd have y equals 4 minus 2 times 0.5 to the 0 power. And anything to the 0 power is 1, so this whole blue thing is nothing more than the number 1. And so that'll give us 4 minus 2 times 1, just 4 minus 2, which is 2. So when x is 0, y is 2, and that's true for answer choice C and also for answer choice B. So using the 0 exponent, we've gotten rid of 2 answers. So next, let's talk a little bit about what a general exponential function is going to look like. If you have y equals a times b to the x, and a and b are both positive numbers, then the graph would look something like this. It'll pass through some y-intercept, and it'll go upward from there. And that graph is the secret to getting rich, because let's say you have an investment account and it's increasing at a certain percent, X number of times, it could end up with a whole lot of money. But in our situation, this A is a negative number because we've got the negative 2 right here. And for the purposes of discussing this, we don't really need to know that there's a 4 here, because what that 4 would do is it would shift the graph upward or downward, but the graph is still the same general shape. So this whole thing that I'm highlighting in purple here is sort of going to give us the general shape of the graph. And there are 2 things going on here that are really important. In an exponential equation, if the b right here is less than 1, then instead of getting a graph that curves upward, you're going to get a graph that curves downward, and it'll get closer and closer and closer to the x-axis. So it'll look something like this, with the x-axis as an asymptote. Or if you want to be literal and realize that there's a 4 right here, it would be that idea shifted up by 4. So we have the b less than 1 because the b is 0.5 in the main format of a times b to the x. And so because this number is less than 1, it would have had that downward slope. So in our first scenario here, we talked about a being positive and b being greater than 1, and it would look like this. Now, if the a term is positive and the b is less than 1, that's going to make it curve downward the way we just showed. But this function takes it even a step further than that, because in addition to having the b be smaller than 1, we also have the a being a negative number. So it's going to look kind of like this curve, But multiplying a whole equation by -1 is going to reflect it across the x-axis. So to show that, it's going to now look a little bit more like this. It's the reflection of this curve across the x-axis. And so now we've got it looking like that. And last but not least, we can think about, well, what does it do that there was a 4 added to it? If you add to the outside of an equation, if you just tack on +4 at the end of an equation, that's a vertical shift, and that's going to shift it up by 4. So if we have the a being a negative number, the b being a number less than 1, and you also have the idea that we're adding 4 to the outside, it's going to be the same as this curve, but it's going to be shifted up by 4. So it's going to look a little something like this now. It's the same curve, but just shifted upward. And you can see how that matches answer choice C for number 14. And by the way, if you're not someone who wants to get really deep into understanding the graph of an exponential function, you could have just picked x and y values and plugged them in. So for instance, I could have said, well, what's going to happen when x equals 2, when x equals 3, when x equals 4, and plug all of those into the given equation, and we would have gotten a bunch of positive numbers greater than 1, which would have demonstrated to us that between b and c, the answer would have been C. Question number 16 is asking us about some of the specifics of solving absolute value equations. So you should have as an instinct that if I have the absolute value of x plus 1 equal to 5, then that's going to be x plus 1 equals 5 without the absolute value, and x plus 1 equals -5, and then you just solve both of those. Now what's the reason for this? The absolute value of 5 would have produced an answer of 5, but the absolute value of -5 would have produced an answer of 5. So if we see that the answer is 5, as we do see here, what we don't know is whether the ingredients that went into that were positive or negative. And so you have to actually play both sides of it, which is what we're doing right here. We have the positive side here and the negative side here. And so we can just solve both of those, take away 1 from both sides, you get x equals 4, and take away 1 from both sides here, you get x is -6. We're being asked for the positive solution, and that's 4 for number 16. Question number 17 is asking us about some random triangle, and in a situation like this, I would just draw an equilateral triangle on my page because it doesn't have to be to scale. You just need something to kind of give you a mental image of it, but we'll label the R, the S, and the T. Angle T is 40. Angle R is 20. And so what does this one have to be? What we're talking about here is the idea that the angles of a triangle need to add up to 180. So 20 plus 40 plus the unknown angle equals 180. Just combine our like terms, take away 60 from both sides, and you get 120, which is the answer for number 17. So going on to number 18, we're just solving a regular equation here. We can start by taking away 4 from both sides, and we'd get 3x over 2 equals 9. And one nice shortcut from here is to multiply both sides by 2 over 3. So when you have your variable multiplied by a fraction, you can solve nice and easily by multiplying by the opposite fraction. So that'll totally cancel the left side, leaving us with x. And on the right side, we have 9 over 1 times 2 over 3. So without a calculator, you can simplify before multiplying. So divide this and this by 3, and you would get 3 here and 1 here. So the answer is 3 times 2 on the top, which is 6, and 1 on the bottom, which we're not going to show. And so it's just 6 for number 18. Question number 19 is a radical equation. And for radical equations, you're going to want to isolate the radical and square both sides. And you're also going to want to plug your answers back in to check whether they're right. So let's go ahead and try that. Squaring both sides of this equation, because we already have the radical isolated by itself on one side of the equal sign, we'll get 14 minus 2x, because squaring the radical cancels it out. And on the right-hand side, we'll have x minus 7 squared, which is x minus 7 times x minus 7. Now we can FOIL out the right-hand side. First times first, outer times outer, inner times inner, last times last. And we have 14 minus 2x equals all that stuff on the right. Combine some like terms on the right-hand side. And now we have a quadratic situation. which we can solve by getting one side equal to 0, and then using preferably factoring, but if that doesn't work, we can do the quadratic formula or completing the square. So we undid everything on the left to get that side equal to 0, and that's giving us x squared minus 12x plus 35. So right now we're looking for two numbers that add to negative 12 and multiply to 35, and those numbers are negative 7 and negative 5. So it's going to factor to 0 equals x minus 7, x minus 5. Now we have the zero product rule that says that if these two parentheses multiply to 0, we can set each one equal to 0. So x minus 7 equals 0, x minus 5 equals 0, and you can just go ahead and solve both of those, and you get 7 and 5. So now, because it's a radical equation, we have to plug these answers back in and check them. So let's check the x equals 7. Square root of 14 minus 2 times 7 equals 7 minus 7. So here we have the square root of 14 minus 14 equals 0, and the square root of 0 equals 0, and 0 is equal to itself, so that did work. Now let's try the 5. Square root of 14 minus 2 times 5 equals 5 minus 7, so that's the square root of 14 minus 10 equals negative 2. And for that situation, that's game over, because you cannot have a radical set equal to a negative number. By the way, you can have a radical set equal to a negative variable. That would mean that the variable itself is negative, but if it's equal to a negative number like negative 2, then that's the end of the road for that option. That's no solution, so this one can't work. The 7 did work, and our answer for number 19 is 7. Question number 20 is a system of linear equations, and for a system of linear equations, you're going to want to use the elimination method. The way to do that is to multiply by something that's going to make one of the variables drop away when you add the equations to each other. So if we're being asked for y, then what we should do is get rid of x. So we can multiply this one by negative 4, and that'll be helpful because it'll give us negative 8x. And that negative 8x, by the way, is going to combine with the positive 8x to eliminate. But multiplying the whole top equation by negative 4, we have negative 8x minus 28y equals negative 16. And we can just bring down the bottom equation, 8x plus 4y equals 12. And when we add straight down, we'll have negative 24y equals negative 4. Divided by negative 24 on both sides, and you get y equals 4 over 24, which is the same as 1 over 6, and that's our answer for number 20. And we want to thank you so much for listening to our video on the April 2021 Non-Calculator Math section, Section 3. And Grateful provides one-on-one and small group SAT, ACT, and PSAT tutoring for students all around the world. Your competition is using a tutor, and probably a good one, so if you want a competitive edge, you should reach out and find out how we can help you to prepare for your next test. Thanks so much, and have a great day.